Hello everyone, welcome to Olsen Cafe. In this lesson, we are going to walk through a calculus question on turning points. This question is taken from 2024 Prelim Paper 1. It is found to be one of the challenging ones, if not the most challenging question many students could not do. So let's see if you are able to do this. So let's take a look at this question. So over here, second derivative is given, and also the gradient of the curve at point A, it is also given to be -2. So what we are supposed to do is to show that the curve has a minimum turning point between x equals to 0 and x equals to 1. Now, if we take a look at the solutions, all right, let's apply KC and SU. So as usual, K stands for the keywords. So in this case, the keywords gradient of the curve. I think most students actually found this pretty easy. So, and with that, right, many able to know that given this gradient equals to -2, they are able to integrate and hence derive dy dx successfully. Now, then the next thing, alright, it says that the curve. So in the first part of the question requires student to actually find the equation of the curve, which student also, most of them found this very easy. So most students able to integrate accurately and to derive the equation of the curve. Now, what is tough is this part here whereby, to show that the curve has a minimum turning point. Yeah, so let's take a look. So over here, let's go through some of the misconceptions that students made during the examination. So the one that students find it difficult, it will be turning point. Yeah, so usually when a student see turning point and then they jump in and trying to apply all the knowledge that they learn about turning point. So this often lead to students, equate dy dx is equals to 0 because this is the condition for stationary point. And then often, all right, when they're trying to solve the equation and then they realize that get them nowhere. Yeah, so the second misconception, it will be having this word show that it is a minimum point. So we also learned that if you want to determine that the curve has a minimum point, all right, one of the common strategy that students use is actually using second derivative test. So let's take a look at the two sample solutions over here. So the first type, it will be students, make use of the second derivative given in the question. And these students actually showed the knowledge and understanding that exponential function cannot be less than 0. So it's greater than 0. So therefore, second derivative, no matter what, is greater than 0. So hence, all right, it is a minimum point. But this solution, if you look at it carefully, right, it doesn't really indicate very clearly, right, because the question says it's between x equals to 0 and x equals to 1. But over here in this solution, which is the point, it says that it is a minimum point, but what is the it is? Where is the it? Yeah, so this is something whereby students struggling with. Now let's take a look at the other solution. So over here, students are more specific, right? It says that when x equals to 0, right, you found that second derivative is greater than 0, and then when x equals to 1, all right, the second derivative, the value derived, it is also greater than 0. So therefore, all right, it concluded that it is a minimum, it has a minimum turning point. But if we take a look carefully, right, over here, did the question says that x equals to 0 and x equals to 1 as turning point? The question did not state that. The question says that show that the curve has a turning point between x equals to 0 and x equals to 1. So, but given these solutions, right, the students are actually to say that x equals to 0 and x equals to 1 are turning point. But do take note, these are not turning point. So the keyword that many students actually missed out, it is actually this keyword between. Right, so this is the main keyword that you need to pay attention to. So with this understanding, if we're trying to put everything together, right, so there is a turning point between x equals to 0 and x equals to 1. So therefore, if you want to take a look, right, a more appropriate or suitable method to justify that there is a minimum point, right, is by using a first derivative test. Yeah, so when x equals to 0, first derivative, so I'm using dy dx. I sub the value when x equals to 0 into the expression, and I'm able to get the value as -2. So you will all know that if dy dx is greater than a negative function, all right, I will have a downslope. Yeah. So similarly, I'll work out when x equals to 1, I'm able to find the value for dy dx, which is positive value. So which means I'm able to have a upslope graph. So given over here, right, so what we know is that, all right, the gradient changes from negative to positive, but exactly where is the turning point, we do not know. But we do know that somewhere, right, between x equals to 0 and x equals to 1, there has to be a turning point, because by looking at the gradient, all right, the slope, we know that it has to be a minimum turning point. Yeah, so understanding this, then we are able to actually write down in words, all right, to show. Because when show, right, that means we have to be very explicit in our explanation. So this is a part whereby often students struggle as well. So do take note of the highlighted phrasing. So this is the one that we will need to state. All right, there are some students who are able to solve this but unable to state the keywords, right, in the proof. So in this case, the keyword I'm going to mention is since the gradient changes from negative to positive. So therefore, the curve will have a minimum turning point between x equals to 0 and x equals to 1. So I hope you have a clearer picture now. Alright, thanks for watching. So if you like this video, do remember to share, like, or leave a comment. And click on the subscribe button for more content. See you in my next video. Bye.